So the title of this talk is, yes, you can run LLMs on Kubernetes. So by show of hands of the few of us that are here, how many of you knew that is possible, that you could run LLMs on Kubernetes? All right, so all of you know, fantastic. So the talk is done. I can just, I'll go. Now, we'll spend a little bit, thank you. Thank you for, getting that, starting that joke on. Okay, let's start this off. So we can run LLMs on Kubernetes for sure, but obviously when you're doing that, there are a number of reasons because, first of all, the companies like Google, which I work for, there is Anthropic, there is OpenAI, they're releasing these AI models as APIs that you can consume. But then why would you want to run your own models on your own Kubernetes cluster or wherever you want to run them? Number one is, first of all, open, your data sovereignty, being able to do your things yourself. So in that, you have many options. Many of us heard about the DeepSeek R1 model that took down the S&P index by like 10 points in a single day when it came out first. So these models are in the being built in the open and coming with capabilities that is in some ways in the free market pushing major providers like Google, Anthropic, and OpenAI to do better, do more, to be more user-centric. So like in some ways, I happen to work for Google, but I'm also a person that is in tech living in this world right now. And tech being better for everybody is generally good for me personally as well, right? So these open models are pushing the boundary and making everything everybody have to level up to keep up. In that, we have many options, obviously. In Google, we also released a model called Gemma. Gemma 3 is out. Llama 4 is out. This slide is slightly outdated. Qwen came out with some brilliant models in recent times. So you have many options, and each of these models are fundamentally good for certain things that you can cobble together to make your own system. In the new agent era, you can kind of get into the world of building agents with smaller models that do very specific things very well. Now, when you're talking about running anything in the cloud, you the previous talk, actually, they talked about the hybrid cloud. So you have this full range of operations. On the very left of this slide, you have the manual, self-managed, where you are like cobbling to VMs, have your GPU cloud. On the very right, you have something fully managed, like you're just talking to like a managed service like Vertex or Bedrock, right? Kubernetes fits somewhere in the middle, right? So it has some good qualities from both ends. You have a lot of control, but you also have a lot of flexibility of management where the managed provider of Kubernetes can do a lot of things for you. So Kubernetes is great for running web apps, and I'm noticing I spelled 4 wrong, which is sad. But the idea is Kubernetes is great for running web apps because it has a lot of the things that when you're building an application, you should not have to worry about. Things like scalability, things like advanced device management, complex, and it works across multi-cloud with hybrid cloud providers, and you have very good control over deployment. Now, so Kubernetes is there. We're going to talk about why Kubernetes is great for that use cases. But let's talk about some of the concepts when you think about running LLMs on Kubernetes, some of the words you should know about, right? Number one, serving engine. LLMs are just, at the end of the day, just numbers. Something has to take your request and handle and process and give it back. And those things are called serving engines. You're going to hear things like TGI, VLLM, Kubeflow has like KServe, and things of that nature. LLM is the thing that you're talking about. It's the machine learning model that are very large and very good at understanding text and giving back some other text, generate stuff. Inference and serving are kind of interchangeable. This is the idea of, again, you make an API call and something happens and it comes back, and that is serving. And then you have accelerators. This is, again, you could run LLMs on CPUs, but they're generally pretty slow. You don't want that. You want faster. So things like GPU, again, NVIDIA stock, NVIDIA's company price went to like $3 trillion because they're the only company at this point like providing GPU at that scale. Internally at Google, we have this one accelerator called TPU, which is also what we use to serve something like Gemini. So accelerators are the general term for things that can do math quickly. Quantization, so each of these models come in various flavors. So usually it's 32-bit, like each number. You could also get faster performance with lower precision by using like 4-bit quantization, 8-bit quantization. So when you're trying to solve these things at scale, you're going to hear things like, oh, we need to quantize this model to be able to fit more onto the same accelerator. Weights are those numbers. So all of LLM are just matrix computation, and weights are those numbers on those matrices that exist. Context window is how many tokens can you fit in a single request or an output. So that when you hear things like Gemini has like a 2 million context window, that means you could send 2 million tokens into the single request and get things back. And bigger context window means you can put more things in the same thing. Smaller context window basically means Smaller context window basically means you could not fit more. So like in a 2 million context window, you could fit like 50 novels at the same time. What is the use case for that? I don't know, but it could. Like, that is the whole point. Again, I kid, but like things like video analysis, when you have like a half an hour long video, you could just fit the entire thing into a model, and the model can give some insight back. That's pretty powerful. And multimodal, which is the thing where you have a single model being able to understand both text, audio, and video. The newer, all the big models that exist in the space, like OpenAI, all the numbers, O1 through 4, and 4, again, I gave up on understanding their numbering model. And Gemini and Claude models, all of them are multimodal, where you can give a text and get images back, give image, get text back, send image, get a video back. So it's kind of like this whole like input array and output array, and that each connect to each other, which is fantastic. All right. Now, we just said, like, again, one of the things you're going to hear about, again, Kubernetes obviously is going to be good for running LLMs because LLMs are the new web app. If you haven't heard it, you heard it here first. But initially, I think it was first quoted by one of our distinguished engineer called Clayton Coleman, who basically, in one of the KubeCon said, inference is the new web app. But inference is slightly different than a web app because if you look at, these are the base images for a bunch of these PyTorch or VLLM, which are the serving engine images. And these image sizes are like 6.9 gigabyte, 9.6 gigabyte, 10 gigabyte. These are not your traditional web app sizes. Maybe for some Java application, but not for most application, right? These are huge images. So your idea of like, I'm going to start an application, and then my Kubernetes cluster has to go off to the internet and download all this data, that takes forever. So like your time to first token or your cold start problem goes really bad in this situation. So let's talk about some more concept. Single host, single accelerator. This is the most common scenario you're going to find yourself. If you have a computer that has a GPU, like a desktop machine, you have a GPU, that is the world where you're in, right? Like you have a single machine and a single GPU that you're talking to. Most cloud providers, when you want to serve something bigger, you're going to get to some world of single host multi-accelerator where you have a single machine that talks to 8 or 16 GPUs, and you can shard the model across to fit that. And then multi-host multi-accelerator. This is where all the biggest models need this because, again, we don't have enough VRAM to put the entire model. So when you're talking about something like Llama 3, 4, or 5 billion, or DeepSeek R1, which was say 671 billion parameter model. So that model does not have, like, we don't have enough GPU on a single machine that you can fit that that entire model. So if you want to do full precision 671 billion parameter model, that's going to take roughly about 2,200 gigabyte of video memory, which, again, if you're talking H100, a single H100 GPU can have up to 80 gigabyte, and single node of 8 H100 can have 640 gigabyte. So you need 4 of those nodes with 8 NVIDIA H100 GPU each to be able to fit it. So you cannot do that, right? So let's talk about what it takes to be able to fit such big models. When you're talking about running LLMs on Kubernetes, it's not necessarily like a one-size-fits-all problem. It's a multidimensional optimization you got to do to get to the point where you could say, I'm doing this with the best cost-to-performance ratio. So first things first, model optimization. This is where quantization and things of that nature comes in. Next, after that is serving optimization. This is where we're doing things like figuring out how do I send the request to the best possible instance of this model. So in Kubernetes, we have a new gateway extension called inference extension. Inference gateway extension, which basically has things like semantic routing, which can understand your request. It can do semantic caching. So if you ask the same question with slightly different wording, it would be able to understand that it's the same question. I can respond the same response back without having to rerun the model again. And finally, accelerator optimization. This is where you're choosing the right GPU or the TPU size to fit the model best. So for some use cases, a smaller model with cheaper use cases, like a cheaper per second cost is better because you want to save money but not looking for the best speed. For some use cases, you actually want the best, fastest GPU and TPU possible. All right, so the last thing, I think some of that is just exporting. Like it's not, I didn't spell all these words wrong. I'll show you the slide later if that doesn't work. But the idea is when you think about, I want to set up an inference server for myself, this is what you're looking at. At the very bottom layer is your compute. This is all the things you're using to run the workload. Just above that, it's some of the things like time sharing, GPU sharing, and your storage, your networking. Above that is auto-scaling, things that come from Kubernetes, placement and provisioning. Above that, one of the things we think is going to help, it's another CNCF project. Well, it's part of Kubernetes SIG, batch SIG, called Q, that can do some fair sharing semantics. We're using Kubernetes API. Above that is things like you want to build something like self-service, cost management, RBAC, and multi-tenancy. On top of that, all of that together builds your ML platform. And this is all infrastructure still. Right outside that, it comes in all the other tools that you want to use, things like Ray, Airflow, MLflow, Kaggle, all the things that comes together to build your platform. And outside of that is your ML experimentation, right? If you're building not just for serving, but things like for training and fine-tuning, your ML engineers are using something like Jupyter. They're using something like Ray Data. All of that can run on top of that thing. So that seems like a very complex image, and which it is, because again, it's a lot of things had to be productionized very quickly. But if you want to build and run and serve LLMs in a production environment, this is what you kind of like in the final picture needs to look like. So with that, I go into the next slide too far. Hold on, go back one. This is jumping 2 slides at a time, I think. OK, I'm missing one slide in between. No, that slide said thank you. So thank you so much for joining. We didn't have enough time to go through all of these things in much detail. But if you do have any questions, if you're trying these things out, do ask me. I'm going to be right outside. We can talk more about it. So thank you so much for joining.